Hello, and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will be doing a homework problem from section 10.1. This is problem number 1. A question asked, does the average Presbyterian donate less than the average Catholic in church on Sundays? So they collected data. 47 randomly observed members of a Presbyterian church donated on average $23 with a standard deviation of 7. And then 47 randomly observed members of Catholic church donated an average of $24, standard deviation of 6. So generally, it might be nice to come up with a table with the information. So maybe we'll just do a quick table, and we have Catholics, or I guess Presbyterian was done first. Let's just call it P for Presbyterian. And then I want to say this is going to be our first sample, and then the Catholics, and we'll call that second sample. And so our X bar for each are going to, well, one of them was 23, the other one was 24, 23 for the Presbyterian, 24 for the Catholics. Doesn't look like there's going to be a big difference here, so we'll probably not see, we're probably not going to be able to reject the null hypothesis that they're equal, because they look pretty close to each other. It kind of depends on the standard deviation as well. Standard deviations for the Presbyterian is 7, and this was 6, so that's still fairly close to each other. And the sample size N was 47 for each. So just kind of eyeballing this, you kind of see that they're fairly close to each other, so I don't know if there's going to be a significant difference here. All right, for the study, what should we use? Notice that sigma is unknown. The population standard deviations for each sigmas are unknown. And so we're probably going to be veering towards the t distribution. And yeah, I think we're going to use a t distribution. So this is the t distribution, but it's the t distribution for specifically for the difference of two means. Right, that's what we're comparing. So what we're saying is that for the Presbyterian, so here is the statement that they have. And so to translate that, we're looking at the word average as the mean. And so, and this is population 1, so mu, the mean for the Presbyterian, is that less than the mean for the Catholics, which is mu sub 2. So this is going to be our claim. And this has to fit to either H0 or H1, and this does not contain a condition of equality, so I believe that's going to be H1, or H sub A, as we've been calling it, alternative hypothesis. So that's mu less than, or that's mu1 less than mu2. So that means the null hypothesis, H0, we can either write it as mu1 bigger than or equal to mu2, or we can simply write mu1 equals mu2, because we're really testing the equality and we're comparing it to something that's less than. And just as a side note, this is going to be a left tail test. And if we just look at if we look at the symbol associated with the alternative hypothesis pointing to the left, that's really the best way to try to look at this. All right, we need to find our test statistic p-value and decide whether to reject or fail to reject the null hypothesis. So from here on out, we're going to use technology. You're more than welcome to use a calculator, but I have been using Google Sheets. And so here's a little template of what we have here. And what we have here is that a set of population information for population 1 and 2. We're looking for the mean, standard deviation, and the sample size. We need to identify the tail so that we would know how to compute the p-value. Now, the degrees of freedom for this was a little tricky. There's a complicated formula involved in the degrees of freedom that uses the standard deviations and the sample sizes for each of those, and you can look that up in the textbook. But I won't go through that computation. All I can say is that the degrees of freedom will be calculated here, and we will use this information to figure out our p-value. So this is our test statistic, and this is our p-value that would be coming out. Okay, so let's just put in our information. Actually, our information was given here already. We made a little table out of this. So the Presbyterian had an average of 23, has standard deviation of 7, and there were 47 pulled out of this. For the Catholics, it was the average of 24, a standard deviation of 6, and a sample size of 47. And then also we made a note to ourselves saying this is actually a two-tail test. I'm sorry, this is a left tail test, so we're going to use -1 for the left tail, and then enter. So the degrees of freedom is this weird number. Let's just say that's about 90. Let's get rid of this. This was another way to kind of use the degrees of freedom, but that's not really used much in our work. So let's take that out. Before the degrees of freedom would be the minimum value between n-1 for the sample size of the first population and n-1 where n is the size of the second population. We usually look for the smaller one, but in this case we don't really need that information. All right, we got a test statistic of 47 negative 0.4736 and a p-value of 0.2295. So let's put that information down. We got our test statistic, and our test statistic, interestingly, is a negative number, and that probably shouldn't be a surprise because this is a left tail test. We should see stuff happening on the left side. So 0.7436, and our p-value calculation, by the way, the p-value calculation uses the t-distribution function. It uses the t-distribution and then uses the degrees of freedom that was calculated up here. And so that's how they got the p-value. And that turned out to be 0.2295. Okay, so we have, we're setting ourselves up for a small significance level of 0.01. So our p-value, clearly PV, is bigger than alpha. So this is a bigger than, and so we will, because it's bigger, it's not small, so we're going to fail to reject or do not reject the null hypothesis, fail to reject the null hypothesis. Okay, so we're failing to reject the null hypothesis. Essentially what we're saying is that we tried in this hypothesis test to reject this equality, and we can see that they're about the same. We were not able to do that, and the claim, remember, was this. So we're not going to be able to support this claim because we're saying that based on this test that these means are about the same. So here, let's say there's sufficient evidence to conclude that the mean was less than that, so we can't conclude that because we're just saying that they're about the same. So statistically significant evidence to conclude the population mean donate is equal to. We don't usually say, when we say we fail to reject it, we don't really accept the claim, or we don't accept the null hypothesis. So I don't think we can make a statement about the null hypothesis in general. The third one, a result statistically significant. There's sufficient evidence to conclude that the population mean there's insufficient, here's the key word, insufficient evidence to conclude that the claim that the Presbyterians donate less than the Catholics. So I think this is it, but let's read the last one. The results are statistically significant so that there's sufficient evidence to conclude that the population mean. So I think that's very close to that first one, which we kind of said, no, that wasn't it either. So, the first one looked at the actual sample. We don't ever want to do that in our conclusion. So we're always looking at generalizing this to the population. So this would have been good for the good replacement for the first one, but since the first one was wrong, this last one's going to be wrong also. So I think we have our winner here. This is it, to say that we cannot support the claim. There's insufficient evidence to conclude that the amount of money that Presbyterians donate is less than the Catholics. Okay, that's it. I hope that helps. Good luck.